One single bullet fired in 1914 triggered a global catastrophe. That shot, aimed at Archduke Franz Ferdinand in Sarajevo, set off a chain of alliances, declarations of war, and 4 years of unimaginable conflict that later became World War I. A bullet, just a tiny piece of lead, can change the course of history. It's hard to believe something so small can have such a massive impact. But for all the mystery and intrigue surrounding bullets, few people understand how they're actually made. So in this video, I'm going to dive into the fascinating world of bullet manufacturing, revealing just how these deadly projectiles came to be. The metal behind the shot. Different bullets use different metals, and the choice of material is crucial to their effectiveness. Most bullets are made from lead, which is dense, cheap, and malleable, ideal for creating a projectile that can be easily molded into the perfect shape. However, lead alone isn't always enough. That's why many bullets are jacketed, meaning they have an outer layer made of harder metals like copper. This copper jacket helps the bullet maintain its shape and allows it to fly faster without deforming inside the gun barrel. But it's not just about the metals used in the bullet itself. The casing, which holds the bullet and gunpowder, is often made from brass, though steel and aluminum casings are also common. Brass is the go-to choice because it's both durable and easy to machine. The casing's job is to contain the explosion caused by the ignition of gunpowder, sending the bullet flying out of the barrel. It has to be strong enough to hold everything together, yet flexible enough to expand and seal the gun's chamber upon firing. The gunpowder, or propellant, is another essential component, usually made of a mix of chemicals like nitrocellulose and nitroglycerin. When ignited, the gunpowder burns rapidly, creating high-pressure gas that forces the bullet down the barrel. Then there's the primer, a small cap at the base of the casing that, when struck by the gun's firing pin, ignites the gunpowder. Each of these materials, lead, copper, brass, and gunpowder, plays a specific role in making sure the bullet does what it's supposed to do, whether that's target practice, self-defense, or hunting. What's even more fascinating is how these materials are shaped and assembled to create the final product. But do you know what's faster than a bullet? You hitting that subscribe button? Go on, test your speed. Shaping the projectile. The process of shaping a bullet starts with lead, usually cast into small ingots that will later be molded into the bullet's shape. To achieve the precision needed for a high-quality bullet, the lead is melted down and poured into molds. These molds are often very specific, designed to create bullets of a precise caliber, weight, and shape. After the lead cools and solidifies, the bullet is extracted from the mold and often undergoes additional machining to refine its shape and size. For jacketed bullets, the process involves adding that copper or steel jacket we mentioned earlier. This is done through a process called swagging, which involves pressing the lead core into a preformed jacket under high pressure. This ensures a snug fit and gives the bullet its aerodynamic shape, which is crucial for accuracy. Hollow point bullets, for example, have their tips carefully cut to create the cavity that will later expand on impact. Even a slight miscalculation in this process can lead to a poorly performing bullet. Once the bullet has been molded or swagged, it undergoes a process of tumbling, where it's placed into a machine with polishing materials to smooth out any rough edges. This gives the bullet a sleek, smooth surface, which helps reduce friction as it travels down the barrel of the gun. A bullet that's too rough could wear down the inside of the barrel or lose velocity, so this step is essential. Whether it's a hollow point designed to expand or a full metal jacket intended for deep penetration, the shape and precision of the bullet are critical to its functionality. After shaping, the bullet moves on to the next stage, loading it into a casing along with gunpowder and a primer. Casing and priming. Now that we have the bullet shaped, it's time to marry it with its casing. As mentioned earlier, the casing holds the bullet, gunpowder, and primer. The process of loading a bullet into its casing is called cartridge assembly. First, the casing is primed, meaning a small amount of explosive material is added to the primer pocket at the base. This primer is what ignites the gunpowder when the firing pin strikes it. Next comes the gunpowder. Depending on the type of bullet, the amount of gunpowder can vary greatly. For example, a high-velocity rifle bullet will require more gunpowder than a low-velocity handgun bullet. The gunpowder is measured and loaded into the casing with extreme precision, as even the slightest variation can affect the bullet's performance. Too much powder and you risk overpressurizing the gun. Too little and the bullet may not even leave the barrel. Once the primer and gunpowder are in place, the bullet is seated in the open end of the casing. This is done using a press that carefully aligns the bullet with the casing, ensuring a snug fit. The goal is to seat the bullet deep enough to be secure, but not so deep that it affects the gunpowder's combustion. After the bullet is seated, the casing is crimped to hold everything in place. This crimping is especially important for bullets that will be used in high-pressure firearms, like rifles or shotguns. Quality control. Whether the bullets are for hunting, law enforcement, or military use, a faulty round could spell disaster. Therefore, manufacturers go to great lengths to ensure that every bullet meets strict standards for reliability and performance. This process begins with a visual inspection of the components, the casing, primer, and bullet. Any visible defects, such as dents in the casing or improper crimping, can immediately disqualify a round from passing inspection. But visual checks are just the start. Manufacturers also perform a series of tests to ensure that the bullet will function correctly under various conditions. For example, they might weigh the bullet to make sure it matches the specified weight for its type and caliber. Even a slight deviation in weight can impact the bullet's trajectory, velocity, and overall accuracy. Similarly, the amount of gunpowder in each round is checked to make sure it's within a very tight tolerance range. Too much or too little powder could result in misfires, underperformance, or dangerous overpressurization. In some cases, bullets are randomly selected from batches for more rigorous testing. This includes firing them in controlled conditions to test their velocity, accuracy, and reliability. For higher-grade ammunition, such as that used by the military or law enforcement, the testing standards are even more stringent. These bullets might be subjected to extreme temperatures, humidity, or mechanical stress to see how they perform under challenging conditions. Once the bullets pass inspection, they're packaged and labeled. But even at this stage, there are still rules to follow. Bullets must be packaged in a way that protects them from damage during transport, and they must be labeled with specific information about their caliber, type, and intended use. The final product is now ready to be shipped out to gun stores, military bases, or shooting ranges around the world. Specialized bullets. Not all bullets are created equal, and as technology advances, so too does the complexity of ammunition. While the basic components of a bullet remain the same, projectile, casing, gunpowder, and primer, the variations are endless depending on the intended use. For example, bullets designed for law enforcement or military use often come with additional features like tracers or armor-piercing capabilities. Tracer rounds, for example, have a small pyrotechnic charge in the base of the bullet, allowing it to leave a visible trail as it flies through the air. This is particularly useful in low-light situations or for adjusting aim on the fly. Then there are armor-piercing bullets, which are designed to penetrate heavy barriers, like bulletproof vests or even light armored vehicles. These bullets typically have a hardened steel or tungsten core that allows them to punch through tougher materials. In contrast, hunting bullets are often designed to expand on impact, creating a larger wound channel to bring down large game more effectively. This expansion is crucial for ensuring a quick, humane kill, and it's often achieved by using hollow point bullets that mushroom upon impact. Another fascinating type of bullet is the frangible round. Made from compressed metal powder, these bullets are designed to disintegrate upon hitting a hard surface. This makes them ideal for use in environments where ricochets could pose a risk, such as indoor shooting ranges. While frangible bullets may sound like they'd be less lethal, they're still quite effective for self-defense and close-range shooting, as they break apart inside soft targets, creating multiple wound channels. As firearms technology advances, so too does ammunition design. New materials and production methods are constantly being explored to improve bullet performance. For example, lead-free bullets made from copper or other non-toxic materials are becoming more popular, especially for hunters who want to avoid contaminating their environment with lead. These bullets perform just as well as traditional lead bullets, but they're better for the environment, a small but significant step forward in ammunition technology. Which part of the bullet-making process stood out to you? Share your thoughts below, and don't forget to like, comment, and subscribe for more content coming your way.